Let's evaluate the integral of the square root of 1 minus x squared. Now we'll be using trig substitution, and in trig substitution there are three different parts. This part we have a squared minus x squared type of integral, with a squared being 1, so we can assume a equals to 1. The substitution for integrals like this is x equal to a sine theta, and for our case, since a is equal to 1, x will be sine theta. Then differentiating, we have dx is cosine theta d theta, and also squaring both sides, x squared becomes sine squared theta. 1 minus x squared is 1 minus sine squared theta. Using trig identity, this is cosine squared theta. So our integral becomes the square root of 1 minus x squared. 1 minus x squared is cosine squared theta. Dx is cosine theta d theta. Now we can assume square root of cosine squared is cosine. So this gives us cosine of theta times cosine of theta d theta is our integral after we made this substitution. And that, of course, is the integral of cosine squared. In an earlier video, when we did trig integrals, this was actually solved. But I'm going to go ahead and repeat that here, how to solve this. This is an important integral that you should know how to readily solve. We'll use another trig identity, which is cosine squared theta equal to 1/2 times 1 plus cosine of 2 theta. And now this is an easy integral to solve. This is 1/2 theta plus 1/2 times 1/2 sine of 2 theta. And this is now equal to 1/2 theta plus 1/4 times sine of 2 theta. But sine of 2 theta, because remember we have to leave our answer in terms of the original variable x, not in terms of variable theta. Sine of 2 theta can be replaced with identity 2 sine theta cosine theta. And that's what we'll be doing here. And let's simplify this. We have 1/2 theta plus 1/2 sine theta cosine theta. Now we have to return to x for our final answer. Remember, our substitution was x equal to sine theta. Taking inverse sine of both sides, we find that theta is equal to inverse sine of x, which is, depending on which book you're using, is also called arc sine of x. So we have the theta here. Sine theta is x, so we have this part. We just need to find what cosine theta is in terms of x. And to do that, we'll be using a triangle from the original substitution. So here's what it looks like. Our substitution was sine theta equals x. I'll write it like x over 1. We're going to form a right triangle that looks like this. This is the right angle. We'll call this angle theta. Now sine is opposite over the hypotenuse. So sine theta equals x is equivalent to opposite side being x and the hypotenuse being 1. We have to complete this missing side. Let's call it a. So a squared plus x squared equals to 1 squared, or a squared equals 1 minus x squared. Taking square roots, we'll take the positive. A is equal to the square root of 1 minus x squared. And oftentimes that happens, that you have the integral itself, the square root of the integral, is being your missing side. So make sure, of course, when we have 3/2 power in the integral, that can happen, but that's what usually happens. We do have the radical that you find in the integral. So we're going to return to the original integral. The original integral was square root of 1 minus x squared. After making the substitution x equal to sine theta, we found the answer in terms of theta, 1/2 theta plus 1/2 sine theta cosine theta. And so now the final answer in variable x is as follows: 1/2 inverse sine of x, that's our theta, plus 1/2 sine theta is x, and from the triangle cosine theta is adjacent divided by the hypotenuse. That would be the square root of 1 minus x squared. And that's the final answer if we now add the constant of integration c. So the integral square root of 1 minus x squared using this substitution is the answer for it is right there. For more videos,